My name is Jasper Bongertz, or Jasper, or Jay, whatever you want. I work still for Airbus Cybersecurity, not much longer, but a little bit longer. And I'm going to talk about how to mess around with capture files, trace files, PCAP files, whatever you want to call them. And, well, come on, think, do something. I do a couple of things forever. For example, network analysis and forensics since 2003. There are a lot of people who do that longer than I do, but I did it more frequently from that point on. So very often reading capture files every day for years. So that gives me an advantage over some people who do that for 30 years. And I've started with something called NetX-Ray that was merged into Sniffer, Sniffer Pro, Sniffer Distributed. Then there was something called ClearSight. If you don't know them, it doesn't matter. Ethereal, I think, with 0.99 something. My problem always was the filter syntax. I was scared of that, so I didn't dare to use Ethereal. And then finally, when I made the jump, well, here I am now. I'm the creator of TraceWrangler, which is the tool this talk is going to be about. And I write a blog at blogpacketfoo.com. I think some of you may know it. Who knows blogpacketfoo.com? Quite a few. Okay. The blog itself is, I don't write a lot, or that means very often. There's long pauses between posts. Usually I write blog posts when I want either to keep something in mind or be able to look it up later because I keep forgetting things, or because people ask me the same question over and over and over and over again so that I just can point them to the blog post. So it's basically like a online repository of things you can do in network analysis. I think the most called page ever is the how do I steal passwords with Wireshark, and that is not surprising, but well, people keep for that thing. 7 out of 10 search queries that end up on my site are for that thing. So the agenda is quite simple. We're going to talk about TraceWrangler. What is it? What do I do with it? Then the file and task concepts. Editing files, extracting packets, and I have a lot of demos and scenarios. I will probably run over time if you don't stop me, so please stop me. And TraceWrangler itself is a, so to speak, trace PCAP file manipulation toolkit. So what it does, it is reads PCAPs and it does something with them. It's different than Wireshark in a way that Wireshark reads PCAPs to show you something. TraceWrangler doesn't show you packet details or anything. It is there for you to change things, extract things, modify things, and then use the results in Wireshark. So it's like a preprocessor of sorts. The most used feature probably today is still sanitization, anonymization. I can never decide which one to use. It's either or. Basically, it means removing sensitive details from capture files, like IP addresses, MAC addresses, upper layer content, whatever you want, more or less. Then another function is a layer removal and manipulation feature. That comes in handy if you have a capture that has a protocol layer that your tools don't understand. For example, sometimes you get a capture from a firewall and it prepends a certain firewall-specific layer before the packet starts. And Wireshark can deal with that usually, but some other tools that you might be using can't, and TraceWrangler can get rid of that for you. I will show how that works. And then there's packet and flow instructions, which is very useful if you have a ton of packets. The biggest thing I've done with TraceWrangler in one analysis job was about 4 terabytes. Well, I could only load 600 gigabytes at one point in time, but 600 gigabytes in one go is more than Wireshark usually can do. At least I haven't seen it done yet. And then there's merging, and merging is not that important anymore because MergeCap, the Wireshark tool, is getting better and better with it. So we'll probably skip over that. So there's a little comparison because people always want to know what's the difference between Wireshark and TraceWrangler. Wireshark decodes everything on this planet almost. TraceWrangler only 35 protocols, and that is because I wrote all the decoders myself, and I'm a single person, and it takes forever. Even decoding TCP can take forever if somebody builds in a new option and you suddenly have to decode that. So it's not that fast. It's the most important ones, of course. Wireshark can display decoded protocols. TraceWrangler doesn't. It just works with them, but it doesn't give you like the tree and all the decoded fields and stuff. But TraceWrangler can hold a list of hundreds or thousand files, so you can do the things you want to do to a ton of files at the same time, which is quite useful because in Wireshark you always have only one file. Even if you merge files into Wireshark, it's in the end just one file that you're working on, but TraceWrangler can work on a set. Filtering is really powerful in Wireshark and almost non-existent in TraceWrangler. It's only for some helpful things. And then there's a statistics that are put in that give you the statistics of all the files in the file list. So if you have like 100 files in your file list, it will open the conversation statistics just like in Wireshark, but across all the files. So everything combined into one single statistic. And then there's almost no or manual packet manipulation functionality in Wireshark, and that only in the GTK version, not in the Qt that we are using now. So if you're using Wireshark 1 point something, there's an experimental feature where you can edit packets in Wireshark, but that is rarely used, and TraceWrangler, it does it fully automatic with lots of features. So, first of all, the file list. So this is how it could look like. We can see here we have a total bytes of, I think that's close to 5 gigabytes right now, 7 million frames or 8 million frames in there. It's 20 files, that's all in the status bar. You can see this is a Windows tool. Unfortunately, I don't have a Mac or Linux version yet. I hope I will be able to, but that is another thing I need to do. And you can see in my list I have a file type, pcapng. Each file is 250 megabytes, and they have a frame time where they start. So if you add files to TraceWrangler, it will sort the file list by frame time of the first frame. So it doesn't matter what you name the files, it will just rearrange them so that they're in time order, and it will do that automatically for you, so that whatever you do will always be consistent, that nothing is changed which shouldn't be changed at that time, so it always does that. It also detects the file type by looking at the file itself and not by the file name, so you could name your file whatever dot whatever, and it will still detect it's a pcapng file. So, duration, number of frames, we don't care, status, whatever. If you have a file that is already scanned, because TraceWrangler usually scans each file to detect what is in there, and I will have another slide set for that, or I have a couple of slides for that. If a file was scanned, you can see here a statistics of what is in that file. So that is sometimes helpful. Adding files is simple. Just use the add button. I will go through this quickly because we will see that live later. There's a couple of things that you can do. I usually do drag and drop because it's the easiest for me. But you can also add them via command line parameter. That is something tools sometimes do, that call TraceWrangler from another tool, and then they pass over the pcap file that you want to use. And of course, pop-up menus and stuff like this. So the indexing thing is important. That is something that Wireshark doesn't do, and TraceWrangler does it. There's a couple of other tools that do the same thing. Basically, what usually is true is that a capture file never changes, right? So once it's captured and written to disk, it stays the absolute same. There are a couple of exceptions, but usually when you have it, it is like it is. And what I do is I ran over it with TraceWrangler when you add it, and it creates metadata about conversations and other things. So that TraceWrangler knows exactly where is the first packet of a conversation, where is the last one. So carving packets from trace files is really easy if you know that you can stop because there's nothing more from that conversation in later files. Right? So having that database of what is in the file is really helpful to speed up things a lot. Because other than that, you would always have to read everything because you have to assume there may be something that you still need. And if I scan the file once, I don't need to guess anymore. So the results are written to a database that I can look up then. And there's a scan threshold, because some people don't like the scanning thing. There's this auto-scan threshold, and you can say how much bytes the file must have at maximum to be scanned automatically. You can always scan manually, but if you want to scan it automatically, there's a limit, or you put in 0 and then it scans everything. So I usually have a 0 in there. The database name and location can be configured. Usually it is put in the same directory where also the original PCAP files are, or PCAP-ng files are. If you want to have something else, just configure it. And this is how it looks like if you scanned, for example, let's say we scanned D3, you will have a database file that is called traceintel.db or whatever you configured. And in there is the information about what was in the files. So you can see there's like, I don't know, first frame time, last frame time. It will have IP conversations over there. I think here you can see there's some tables where all the statistics are kept, and with that I know what's in the files. So you can also couple that database with your files if you want to give it to somebody else, and as long as it's in the same directory, TraceWrangler will find it and use it. Okay, so to tell TraceWrangler what it should do, there's an adding tasks area, and usually you either say anonymize, extract, edit, or merge. And there's also a couple of tools that I'm going to show. But since slides are not that funny, I will go through them really rather quickly. So, anonymization. What's anonymization? Anonymization means you remove sensitive details from PCAP files, and that is something that most speakers at SharkFest are really glad for or thankful for, because they can prepare their demonstration PCAPs without exposing what customer they took it from, or where it was captured actually. You can change a lot of details, and we will look into that in the demo. It has a default set that usually works in a way that you don't expose any critical stuff anymore. So even if you don't know what you're doing, you could just add the anonymization task, accept it as it is, run it, and then you end up with a file that is basically not containing any critical stuff anymore. The problem with that could be it cuts away too much for you, so you want to keep something that is cut away, then you need to change the settings. Or you want to do something more than what it does by default, then you also need to change the settings. So it can be overridden. You can define a new default if you want to, and there's a factory default that you can always restore if you want to. So sanitization, that is important, is a four-step process. The first step in that is that you need to parse or analyze each packet from bottom to the top. So you start at the bottom, you find maybe Ethernet, and then you think, okay, what's the next one? Maybe it's IPv4. So you need to parse all that. You need to extract all the values. You need to understand all the protocol fields, right? Because you cannot anonymize anything if you don't know what it is. So the first step is always understand the packet as much as you can. If you hit something that you can't understand anymore, and TraceWrangler doesn't have so many protocols, so at some point it will stop doing that. For example, HTTP is not in there yet. If it hits HTTP, it's like, I don't know what this is, and it considered its unknown payload, right? So the next thing is all the values are extracted from the parsing, and then all the details that need to be changed, like IP addresses, MAC addresses, port numbers, VLAN IDs, whatever you want to change, will be changed and replaced with the new values. And we will also remember, what did we do? Which IP address was replaced with what other IP address, so that you can keep it consistent. Because always replacing something with something else doesn't really help you if it's not consistent. Yeah, so you need to replace one IP address with another, and always in the same way. Then you build a new packet top down. So basically what happens, or what that means, is your original packet will be discarded. It is not transported over to the new file. It is read completely, taken apart, replaced, and put together again. So that's another difference where TraceWrangling is different than Wireshark. Wireshark only parses packets or dissects them. It takes them apart and pulls the values out, but it doesn't put them together again because there's no need for that, right? So that's what I have to do. I need to pull it apart, interpret it, build a new one, put it together, write it. And the most important thing here is if TraceWrangler doesn't understand something, it cannot survive this process. It must not survive the process because it may be exposing something that is critical. So the principle is that if TraceWrangler doesn't know what it is, it will not make it to the newly constructed packet, unless you configure it to do so. You can always override that and say, if you don't understand it, just keep it and put it into the new packet. Okay? So we have 24 protocols. This is just a list of my development environment where you can see there's IPv4, ICMP, GRE, Ethernet, DHCP, ARP. I can even do some wireless stuff in the meantime. There's NetFlow, there's TCP, UDP, VXLAN for the virtualization people. So I put in whatever I can when I have the time. And the most important thing, what I just mentioned, is this setting here. This says remove all unknown layers and cut away the packets from the bytes from the packet. So if this is checked, this makes sure that nothing that TraceWrangler doesn't understand makes it into the new packet. If you uncheck this, that is your responsibility because then you're carrying stuff over that TraceWrangler doesn't understand. Yeah, there are situations where you can do that because, you know, for example, you have HTTPS, it's totally encrypted, nobody can do anything with it anyway. You want to keep it, go ahead. Question, sir?
So it'll keep, if you uncheck this, it'll just keep all the data it doesn't know.
Yeah, it keeps everything it doesn't know and puts it back into the packet. Usually that means like you're replacing IP, TCP, whatever, and then it hits, let's say, HTTP. And if you uncheck this, HTTP in clear text will make it into the new packet with the new IP addresses, new MAC addresses, but it will be there, yes. Yeah, so what I will do in the future, because this is annoying me as well, I want to make it configurable so that you can say only remove the payloads from packets that are from a certain IP address, or so that you can define a criteria when to remove it and when not to remove it, because right now it's either remove it all or never. And that is annoying because sometimes I have a trace where there's like 10 conversations in there and I want to remove everything except for one conversation where I know I need to show this. Right now you cannot do it. I have seen people who pull the trace apart, anonymize one in this way, anonymize the other one in that way, and merge it together again. And that is, I don't like that. So I want to make it more simple, but that's for the future. Okay, so let's do a demo about this. Any other questions so far? Kinson? If you cut, the question is if you cut, do I replace it with zeros? It depends, you can configure it. I will show it. So this is how it looks like. Let's add some files. I have a very simple example here that's just a PCAP with some HTTP in there. Let me show it to you. So this is just HTTP, right? It's pulled, I think it's even from TraceWrangler, I don't know. Yeah. So this is just a simple HTTP transfer back when my website wasn't HTTPS encrypted. I keep using this because it's readable and it's nice. I think it's good that we use HTTPS more and more, but for us network analysts, it's like, can you please not encrypt your stuff? But from a security point of view, it's good, of course. So this is what I'm going to use now. And where's my TraceWrangler? There it is. So it's in here. I can click on it. It has been scanned. It knows it has 19 frames. It can tell me what the first frame time was, the last, the minimum frame size, the maximum frame size, and everything else. It even checks if the time order is correct. So if you're capturing packets sometimes on multiple interfaces, they get swapped around. And TraceWrangler will check for that kind of thing. So if the times are out of order in time, it will tell you. So let's do an anonymization task. And here is the remove all unknown layers thing. And you can decide if you want to cut them away, then the packet will get shorter and the bytes will just be omitted. You can also go in and say, I want to replace them with zeros. Yeah, that would be possible. And the last thing is you could put in a pattern. So if you, for example, have an exercise where you want to have the trace file just as big as the original was because you want to make it hard for your students, like this was 10 gigabytes as an original file. I want it to stay 10 gigabytes because I want them to suffer when they load this. You can do that, and I've done that before. So in that way that you either put in zeros. Zeros is helpful because if you want to compress it for transfer, then zipping it is really like zip, making it small. Or sometimes I do something like this. I can put in like a remark that it's payload removed by TraceWrangler, which is kind of like an advertisement in the packet so that everybody knows what TraceWrangler is because nobody does. Or you could put in some other kind of message, whatever you want. So let's say we do that. As you can see here, there's also other options. You can decide that you want to cut everything after a certain layer. Let's say you want to cut everything after the TCP layer. So some situations require that you just say, discard everything after TCP, because I don't need it. Yeah? Then you can do that. As you can see, you can even combine that. So for example, if you use it like this, any packet that is on TCP or UDP or SCTP, which I can't pass yet, it would be cut away and you wouldn't see the payload replacement pattern anyway, at least not for UDP and TCP. But if you have like an ARP frame or anything else that carries something that is unknown, then it would appear there. And the third thing you can do is you can cut at a specific offset and say, cut everything away after 54 bytes. And you can combine all these to your advantage. You can use one of them, none of them, all of them, whatever you want. So let's say we don't do this, we just replace it with this pattern. There's some PCAP-NG stuff that I'm not going over because I'm going to have a PCAP-NG talk tomorrow. And I want to save some time. There's 802.11 and you can replace the SSIDs of the Wi-Fi networks if you want to. Sometimes you may be, try to hide what the network is that you're seeing. And you can replace them either by list or automatically. Ethernet is replacing MAC addresses. The interesting thing here is you can now add a MAC address to replace, but usually you don't know what is in the trace file, right? You would have to open the Wireshark and look at the MAC address and then write it down and get it over, and that is just, I'm really lazy. I don't want to do that, and I use TraceWrangling a lot. So what I did is this. I have this database that I told you about, right? This meta database. So what I have here is I have a lookup. And the database tells me these are the MAC addresses that you have in this trace file. I already know that. I don't have to look it up. It's known. So I can just go and say, well, replace that one with, I don't know, 01, 02, 03, 04, 5, and 6. Okay. Yeah, so I have it in there. It's really easy to do that. If you have larger things, you can even import from a CSV file, comma-separated value. So you can prepare something that you're reusing all the time and just import it. And then there's an auto thing, which sometimes works. Now it does. What it does is it just replaces them with an automatic value, and you can go in here and edit it if you want to. So I try to make it as easy as possible for you not to write too much stuff, but get as much as I can from what I already know. If something is found in the trace file, I'm going to remove this one, that isn't in the specific list, the specific list takes precedence, so that is always used first. If a MAC address is found that is not in the list, then TraceWrangler checks, hey, what should I be doing with the rest of them? And you can see down here, there's once again the option to randomize MAC addresses or zero them. Or you could also uncheck it. No, you can't. Okay, where's the uncheck gone to? Yeah, that's a problem. I have to fix it. You can decide what to do with it. So usually there must be an uncheck box so that you can disable this kind of thing. That happens if you compile this on the same day you're doing the presentation, right? Stuff changes and you get into trouble. Okay, then another thing that is really important and is always the same that is the same problem for all the protocols. If you change a packet, what happens? The checksum is not correct anymore, right? So you need to recalculate it. But if the checksum was bad before and you recalculate it, it's now good. So for a network analyst, that is like, I want to know that it was bad, right? So the default mode is keep bad checksums bad. So TraceWrangler will fix the checksum by recalculating it. It cannot just stay as it was originally because that now may be after the sanitization by chance the correct one. So I need to recalculate it, and to make sure that it's not the correct one, I add a +1 and then it's bad. So that is the simple way to detect that I recalculated the checksum. If you ever see a checksum in Wireshark where it tells you it should be this value, and you see it's this value that it should be +1, it's probably because somebody sanitized the trace file. Okay? That's the easiest way to get it right. So then there's VLANs. You can remove VLAN tags. I don't want to go into that much. There's tunnels like AIA that doesn't exist anymore because the company who used it is gone or not using it anymore. MPLS. Some of you may know MPLS label stuff. Yeah.
Is there still an option for leave the vendor octets intact?
Yeah, it should be, but you're right. It disappeared as well. And I will tell the reason why this all disappeared later, but you're absolutely correct. There will be an option, or was an option already earlier, that you could leave the 3 first octets intact because that tells you the vendor. What happened here is I forgot to change the drop-down box. There need to be 2 more values in there, like keep original and keep vendor octet. But I forgot to add it, so that's why you don't see it. All right, good questions. IPv4, this is something where you can now probably wonder what happened here because I didn't do anything, right? You can see there's IP addresses up there, but I didn't do anything with them, okay? So there's a so-called auto mode up there. You can see that is, this one, auto mode. Auto mode means if you put a trace file into TraceWrangler where only 2 IP addresses are in that file, it will automatically replace them with 192.168.0.1 and 10.10.10.1 based on who is the server and who is the client. The client always gets the 192.168 and the server always gets the 10. Whatever, so that you can basically avoid doing that yourself, and you always know, this is the client, this is the server. The only time it doesn't do that and cannot do that is if it detects that both IPs are in the same subnet. Because if they're in the same subnet, this would be wrong, right? They cannot be in totally different classes of IP addresses. So what TraceWrangler does in the background, and you don't see it here, of course, because it happens so fast, it calculates how far are they from each other. Is there a router in between? If it sees a router or a router, or whatever you want to call it, it will give them all these addresses, and if there's no router, so it knows they're in the same subnet, they will both get a 192.168 IP address. Different ones, of course, but in the same subnet, so that is automatically kept that way. If you don't like this feature, just remove the auto mode. I sometimes call this the Hansang mode, if you know Hansang Bae. He likes it to do it this way, and I put it in for him basically so that he can do things faster. So for me internally, that is the Hansang mode. Once again, you have to look up the import and the auto mode here. You can also replace IP addresses by subnet, so you can just change whole subnets and keep the host part. To do that, you need to define, of course, the subnet mask so that I know what is the host part. Okay, so we could do that and do something like replace 192.168.124, 0/24 by, I don't know, 192.168.1.0.0/24. And you can see it gets red and black sometimes. That is when it's checking if the format that you inputted is correct or not. So let's do it that way. And then there's a lot of features where you can tell it to randomize addresses, including multicast, because usually multicast should stay multicast. It doesn't make any kind of sense to randomize those. APIPA addresses, these are the 169.254 addresses you get if there's no DHCP. That is a problem in itself, so randomizing those to another value may take away the information that there was something wrong with the DHCP. And then there's documentation IP addresses that few people know about. So also IPv4 has a documentation IP address range that you can use as example IP range in your documentation. And if it finds this, it will keep it and not replace it. So, and this will tell it what to do with the rest. Do not randomize. So this is how the Ethernet thing should have looked like. Do not randomize and all the other options. Okay, then there's IP identification and all that other stuff. But I think we're done now. If you want to dive into this stuff, I will let you do that yourself because I don't want to burn too much time with this. Question?
So if you rip out the TCP payloads, you change the IP length, put it down to 0, put it down modified by TraceWrangling or whatever, you calculate that IP length, or you use that?
The question is, if I remove the TCP payload, do I change the IP length? Because the IP length defines how long the packet is, because TCP doesn't have its own length field. No, I keep it as it is, because otherwise the TCP dissector in Wireshark would go crazy. If I did that, the Wireshark dissector would think that the packet is shorter than it should be, and it thinks there are gaps in between. I don't do that. What I do is, if you remove the payload, I will reduce the captured size. You know, each packet has a length that tells me how long was it original and how long is it right now, how much was captured of that original length. And if you reduce it by cutting away the TCP length, I will adjust the captured size so that it matches what you have in the packet, so that Wireshark doesn't get confused. Otherwise, everything would be black and red. Thank you, good question. All right, so I will just let you play around with it if you want to. The one thing that you need to understand from a sanitization perspective is, right here it looks a little bit like we have an Ethernet layer, an IP layer, a TCP layer, whatever, but that's not really true. What we do here is we define the replacement options. So in an ARP packet, you have a MAC address, right? At least one, usually two, sometimes IP addresses, but you don't see any ARP in my list on the left. Why? Because the ARP packet just contains MAC addresses and IP addresses, and we can already define them. So any protocol that contains an IP address that I understand, or that contains a MAC address, it will just use the settings that we use here. It's not per protocol layer, but per address type or per value type. This kind of list, okay? So don't worry, it will do that automatically as long as it understands the protocol. And I can tell you, IPv6 gets really crazy sometimes because there's IP addresses in IPv6 that are based on MAC addresses. So if you change the MAC address, you need to change the IPv6 address. There are dependencies that Wireshark, that TraceWrangler does automatically for you without you needing it to tell it. Okay, it's a lot of things happening in the background. Okay, so we just use this one, and then we run it, and I will open the folder for you. There's the folder. And if I run it, there's the new file. You can see it's called http://anon. That's the default name. You can change it in the setting as well if you want to. And if we look at this one now, you can tell that, yeah, this is probably HTTP because it's in port 80, but there's no GET request anymore, there's no response code anymore, everything has been removed. And if we look into a packet, let's say this one, this was the GET request, you will see that, yeah, there's TCP payload, and our payload is this. Yeah, so we interpreted everything, found, oh, this is HTTP, I have no idea how that works. He cut it away, he replaced it with this amount of bytes in strings, and wrote the new packet. Yeah, and if you have something where you need to check, like, let's say, TCP problems, This would work perfectly because you don't need the higher level stuff. So TraceWrangler right now is really useful if you are tracking down TCP connection issues and other things. And if you need to send, for example, a trace file to a firewall vendor so that they can analyze what is going on, very often that is good enough. Yeah, and you don't need to send them your true IP addresses and MAC addresses and whatever. You can just give them a file like this. What it will do? Yes, 1 second. No, it doesn't. Usually it puts a comment in the capture file so that you know that it was sanitized. Yes, question?
You're talking about links with capture link.
Yeah.
TCP link. So that default Wireshark field, is that TCP link or is that the amount that's captured per packet? Did you hear that?
Yeah, I heard it, but you can repeat it and I can
sure.
find the field in the meantime.
So we're talking about links, that the default length field up in the packet list pane, is that TCP length or capture length, the amount that was captured
This
for that,
this
for those
column?
packets?
You mean this column here?
Right, yeah.
That is the full packet length. So that is the full frame Ethernet except the CRC. The Ethernet CRC is usually not in the packet, but this is the full length. If you want to know the TCP length, you can find that here. That is 498, so it's a little less than.
So is that the amount, the number of bytes that's actually in the capture file,
Yeah.
or the amount that the Ethernet header reported?
Yeah, this one is the original amount, including the Ethernet header, and that is the TCP payload length.
Okay. What if you cut each packet like at 68 bytes or something? Then will the original length be reported or the new length?
No, the original length will stay there.
Okay.
It will not be changed because that would be bad, because then all your statistics will be wrong. So basically what happens, it just cuts away stuff, but the length in the column will be the original size.
It'd be a different, you'd have to add a custom column to do captured length or whatever the...
Once again?
Oh, would you have to add a custom column to do the captured length?
You could do that, yeah, because there's in the frame, there's something called the capture length, and you could add that as a column if you want to.
Okay, thanks.
So that's possible. You could also use this field here and make a column out of that one if you want to. So as you can see, this is in square brackets, right? Square brackets means this is not in the packet bytes. This is something Wireshark calculates, and it calculates it from the IP length, which is here. Okay, it knows the IP header length, and it knows this field, and it just subtracts the two, and then it knows how long the TCP payload or the TCP section is.
Is there a way to export the mapping that you use to anonymize the trace?
Well, what I do is I create a database when I do the mapping, and in the database, every field that is replaced will be written down with the original and the replacement. It is deleted by default after the run, but there's a configurable option where you can say keep the database. So that way you know what was replaced in which way. So yes, you can do that. It's not exportable, but you just keep the database, and then you can open it with any SQLite viewer and see what was replaced. Yes.
Okay, since you can do that, can you use the same database for next files?
Yeah, you can do that.
Oh, great.
Yeah.
Thank you.
What I usually do is if I have multiple files that I want to be anonymized in the same way, I'll just add them in one go and let it run over all of them. But the feature is exactly for that kind of thing where you are doing something later with the same settings again, then you can just use the database and replace it that way. Yeah. All right, so that is anonymization. There's another question over there.
Jasper, I see in your trace there that it does have the OIDs for the manufacturers and the codes, for the MAC codes.
Yeah.
So it didn't strip that out.
No, it didn't because I coded it wrong. This version I'm using right now, I compiled it like 2 hours ago, and there's a little bug in there that I need to fix.
But by default, it leaves that in there?
By default, it leaves it in there because it's really useful if you're troubleshooting, because very often you see, oh, this is a printer, this is a Mac device. Knowing the vendor is usually not that super critical, because that is something that I can find out in another way if I was really interested in. I could track other things I really would need to know that. But usually if you are paranoid, and sometimes paranoid is really good, so I'm not blaming you for that kind of thing, you could go in there and say, just blank it out completely. Yeah? It depends on your level of requirements. If you have military networks, which we sometimes do, I'm not even allowed to do anything like this because they don't trust that I know how sanitization works, which is kind of funny because I'm doing that since 2013 and have written the de facto tools that, by the way, the NSA now has in their job descriptions sometimes. They say, you need to have experience in this tool to work this job. And I saw that once and I was like, really? Okay, yeah, good. Yeah, it depends. You can configure it and I need to fix that and then it's possible. Other questions? John?
I was looking at the listing in the help file for additional tools.
You're looking at the TraceWrangler help file?
Yeah, and PCAP touch and NG convert.
Yeah, there's other tools that I wrote. I can touch them later if you want to. That's just help us. PCAP touch is a tool that will read a PCAP file, find the first packet, check the time it has, and use that as a file time. So I use that a lot because if you're working with files, whenever you write them, the file date changes, right? So the original capture was from 2 weeks ago. I read it, I write it, and now it has today's date, and I don't want that because I need to know when it was originally written. So with PCAP touch, it will automatically fix the time for me based on the first frame in the packet, in the trace. Yeah, and the NG convert is just a converter to convert to PCAP NG from very old sniffer formats. You don't need that. Yeah. The documentation, by the way, of TraceWrangler is outdated for 2 or 3 years now because I don't have time to update it, but I will hopefully be able to at some point. Okay, right. So that is sanitization. If you have more questions about that, and if you need it, and if you find it useful, or if you want to talk to me about it, just do that. I will continue with the next part now. So the next one is editing, and editing is actually something that few people need, but sometimes the need is really great. I had somebody who talked to me at SharkFest a while ago, and he said, I have this packet capture that was taken on a Juniper firewall, and there's a special Juniper add-on layer that precedes the Ethernet layer, and because that's in the packets, my other tools cannot read the PCAP files. They can read them, but they don't understand them because there's this damn thing up front. I had a similar thing, I think 3 months ago. I got a capture file from a Cisco fabric path setup. I don't know if you know fabric path, but that is like multiple switches being interconnected with 10G links, and they're using a special header in the front to tell each other where the original packet came from. Wireshark can decode it, but TraceWrangler couldn't, so I had to code that really fast. And when I did that, I also added, of course, the stripping option for that kind of thing. So mostly it's used to remove unwanted layers. I think Simon came up at some point and said, I want to remove VLAN tags, and he didn't find the option. And that was because I put it in there because it was already in the anonymization options, but since people seem to expect it here, I put it in here as well. You can remove the Juniper header. You can remove GRE tunneling if you want to. Sometimes that is important. GTPU is like a tunneling over GPRS, so that is mobile stuff, I think. MPLS shims, CapWeb. Who knows what CapWeb is? That is like a Wi-Fi controller transport protocol, and it transports the original frame for you over another network. And if you only want the encapsulated part, TraceWrangler can just carve that out for you. And here's a Cisco fabric path header, which I also removed. And it will add a comment about what you removed so that you know in the end that there was something more in the packets. So it can de-encapsulate protocols, which are the GTP and GRE tunnel things. It can convert link layer types. Sometimes you have a packet that is captured on, let's say, a Linux cooked interface, which is if you are running Linux and you capture on the all interfaces interface, which is like a virtual interface, you don't get the usual MAC header, you get a LLC header, an SLL header, and you can convert that to a normal Ethernet header if you want to. Sometimes packets are sliced badly, so people cut stuff away without fixing the length values, and it can fix that for you. And I have to admit that some of the features are also available with reorder cap and edit cap, but they're usually much more blunt than what this does, and I will explain that in the next couple of slides. So how does editing work? Editing a packet is not just, hey, find a certain offset, remove this many bytes, and you're done. Why not? Because it is more complicated than that. Let's say I have this Juniper frame, right? The Juniper frame has this Juniper header in front, it has a Juniper link layer type, and after the Juniper frame, the protocol, there's Ethernet. I could just cut away the Juniper frame, but what would happen then? Well, the link layer type is still Juniper. It's not Ethernet. So that needs to be fixed too. Or if you're removing VLAN tags, well, you need to know what the original protocols are following the VLAN tags, so you need to transport them over. And I will show you an example for that in a minute. So basic steps are, does the packet needs to be edited at all? Because sometimes you have a ton of packets in your capture, and just a few have this problem that you're trying to fix. If you have it, or if the packet is relevant, pass all the protocols up to a certain layer. So if I know I'm removing VLAN tags, I don't need to pass IP and TCP because why? I don't do anything with them. So I can stop after layer 2 basically. That saves time. And then I remove the protocols that I don't want and adjust all the fields that I need to. And we will see it here. This is an example for a double VLAN tagged packet with ARP in the end. Down there is ARP. Here's a VLAN tag, here's another VLAN tag, and we have multiple ether types. The first one tells me, oh, the next is VLAN. Then this one tells me, oh, the next one is VLAN also. And then the last one tells me, it's ARP. Okay, so what needs to happen now is I need to cut away the two VLAN layers, but this information that after that will be ARP needs to be kept alive. So in fact, I need to take the yellow field and move it here so that it's seamless again, right? So that's exactly what TraceWrangler does, fully automatic. It will find the VLAN layers, it will cut them away, and it will adjust the ether type so that the new packet looks like this. Yeah, and it does it for all the packets where it finds any of the layers that you want to remove. So it's fully automatic, you don't need to do anything, you only need to select what you want to remove. Now, if you do that with a hex editor or something like that, you're done for, or you're going on for like forever to do that manually. All right, editing packets. Well, we can see if there's a quick example for that. Let's see, do we have something? I think that was a funny one. No, that's just Linux cooked. Yeah, let's use this one. You can see here, this packet has an Ethernet layer, IP, UDP, GPRS tunneling protocol, IP, ICMP. So you have two IP layers, you have the tunneling protocol, and maybe you want to remove the tunneling protocol and carry the data just that is tunneled in the packet. So you just want to remove that kind of thing. So what you would do is you open up TraceWrangler, we remove the existing task, we remove the existing file, we add a new one. Was this one. And then we say edit, remove, and that is GTPU. Okay, run. And now we should have a new one. And as you can see, the tunneling layers are gone, and we have the tunneled payload just under the Ethernet header. Now, this packet, of course, is a little bit lying to you now, because these two layers here, IP and ICMP, were never carried over that MAC address layer. But very often that doesn't really matter to you because you just wanted to remove the layer that you had trouble with. Yeah, so that's what you can do with it. It's really a simple thing. It's not that complicated. The complicated thing is in the background where I do all the parsing and stitching and carving and removing, but that doesn't have to concern you. So I try to hide all that from you to make it easier. Okay, so good. Any question to editing? I mean, editing is something you rarely do, probably. John?
If I've created a relatively complex task, say, including a list of MAC addresses and VLAN substitutions and IP address, and then I export that task, and then I re-import that on another file that I might use later, are there any particular caveats that we might have? Because I had a list that sort of doesn't relate to the new file.
Yeah, of course. If you export a setting and re-import it for a new run, and the new file you're using it on doesn't match what's in your replacements, they just will not happen. You will usually run into the problem that, for example, you have MAC addresses that you want to replace in a specific way, but those are not in the next trace file. Then usually the randomization kicks in and just randomizes with whatever. So usually it does not do something bad, but you don't get the results that you expected. Anyone else? No. Everybody's happy or sleeping already. Who's sleeping? Chris, you're not sleeping. You raised your hand. I saw it. All right. So the next thing is, and that is much more interesting probably, is extracting stuff. Extracting stuff works in a way that you can pull certain packets out of a large number of packets. And usually that requires an idea what you want to have removed or what you want to extract from a larger trace file, right? The most common case that I use or that I encounter is I want to carve TCP conversations from big files. So let's say I have 100 gigabytes of capture files and I need to see one single conversation. The problem is the conversation starts in the first and ends in the last file. Yeah. What do? I could run a T-Shark job and carve that stuff manually with Wireshark tools, but what I usually do is I use TraceWrangler and just throw the stuff in there and extract it. And I will show you how that is done. So the big trick here again is it uses its database because it knows exactly in which file does the conversation that I need start and where does it end. So if I extract something, it knows exactly, oh, I don't need to open the first 3 files because there's nothing in there from this conversation. Then I need to read a couple of files, and when I'm hitting file number 12, for example, I know that this is the last file with packets for this conversation. So I don't need to read the other 80 files that I may have. So extracting is really fast because it knows where to look for the stuff and it can extract it. And I will show you that this is faster than most of the other ways to do this with Wireshark or EditCap or T-Shark, because you can extract multiple things in just one go. You just want to read the files once and extract all the things that you're interested in one go, write them to new files, and then continue, instead of reading it every time again to extract something and having to run all over the files over again. So it helps the user by looking up interesting flows. I will show that. And the most interesting thing here is that you can define the output file name. The output file name looks a bit strange because there's placeholders in there or variables, and you can define in which file something should end up. And I will show that, then it gets much more clearer what that means, because this is really, really powerful. You can keep conversations together, or you can split them or put them in different files depending on how you use the placeholders. And that is something we will see when I demo that, and that is exactly now. So let's say we add some files. Traces, demo, extracting. And let's say I have a couple of files, okay? Let's use 10 of them, for example. As you can see, it's not scanning the files, it's reading the details it needs to know from the existing database. I already scanned them before this talk, so that I don't have to wait here until they're run through, because that would take one loading of each file to do that. So now I have 10 files in here, and it tells me it's like 4 gigabytes and no, 4 million frames in 2.4 gigabytes in total. So what I can do now is I can go to Tools, Communication Details, and that basically opens up a statistics like in Wireshark. And there's a TCP Conversations tab that should look a little bit familiar to you. It is basically showing you the IP addresses, the port numbers, the packets, the bytes from A to B and back. I added a column that tells you the packet ratio, so that you know how much is going from one to the other. And that way you can often spot single-sided connections like this one, 100% going to one side and 0% coming back. So you know this is kind of strange, because it's really one way. And also, I will calculate the initial round-trip time for you. So for example, we could say, hey, let me see all the connections that have really slow handshakes at the beginning. I can sort that column. Okay, now I have to scroll up to the top. In zoom mode, it's a little strange. And we see here there are connections that have a round-trip time, an initial round-trip time, like a handshake time from SYN/ACK of 71 seconds. Now that is not that great, right? I mean, that takes forever. Let's take one of them. Let's say we use one of the less crazy ones, this one that has a good number of packets here. 31 seconds setup time. And now we want to know, what the heck is this? Why is it taking so long? So what I do now, I just double click on it, and you see down here, it will extract the frames. And as soon as the extraction is complete, it will just start Wireshark and open the file for me, I hope. There it is. It just didn't appear it just was in the background. So this is the carved conversation that I just pulled from those 10 files. And we can see here SYN/ACK, ACK. So that is really a long time. So my column setup is strange somehow right now. Let me go and let's use the default one. Okay. So you're all familiar with this kind of setup, right? Is that easy for you to read? For me, it's not that easy because I usually don't use that kind of setup, but let's say we use it here. So we can see it's SYN/ACK, ACK, and the time that it's apparently detected is this one here, 31 seconds, and yeah, there's retransmissions in there. Whatever that is, I think that was one of the traces that was taken on a mobile link. Yeah, you can see here Telefonica Germany. Telefonica is one of the mobile phone companies. So this was basically a mobile device that had a really bad reception or not a great connection. So that is why the handshake was so slow and why there's packet loss. Yeah, but we are not here to troubleshoot TCP right now. We're here to extract stuff, and this is how it works. You basically go into the list of conversations here, and you find something that is interesting, and you just double click it and extract it. And to find interesting stuff, I also added a column here that is called, my screen is too small. There it is. I have a status column where TraceWrangler will tell you, oh, I saw the handshake and I saw the teardown. You have something like new socket closed due to client inactivity. Double click, it's extracted, and then Wireshark should open up. There it is. And we see SYN/ACK, ACK, FIN, ACK, ACK, FIN, ACK. Nothing happened. So maybe this is a problem, maybe it isn't, but you can tell from the conversation statistics, maybe you want to look at this kind of thing. Yeah, usually this behavior, what you see here, if you're doing that for quite some time, you will see that between the handshake and the teardown, there's almost exactly 60 seconds. So this is a typical inactivity timer that tells the stack to, hey, the client contacted us, we granted the connection, but then he didn't request anything, so we just shut it down after 60 seconds of nothing happening, right? So this is like an inactivity thing, and I have some logic in TraceWrangler that will detect that kind of thing. So if I see a handshake and a teardown, and I see that that there's a certain amount of time where nothing happened, I will just call this like closed due to inactivity, right? Okay, so this is how you can extract stuff really quickly. There's other things like SynSend, handshake and teardown, new socket. Oh, there's some red stuff. Handshake and teardown after multi-SYN retry. Let's try that one. And keep in mind that it's always pulling this from the 4 gigabytes over 10 files and combining everything, even if it's spread over multiple files. And we have a SYN, a retry, SYN egg. Yeah, it's not a big thing, but yeah. So I used that actually in a consulting project where a customer told me, hey, we don't have any actual problems, but try to find problems. I was like, cool, what should I be looking for? And they're like, whatever. And what I did is I captured tons of PCAP files, put them in here, and just used this statistics to look at things. And I found a ton of things because I could just extract them, look at them, and I did that for a week. So it was for a week that extracting, looking at stuff. I mean, it was easy for me because I basically could turn in like a report saying, there's nothing wrong with your network. Yeah, but I found a lot of things, so that was what helped me a lot to do that. Okay, also, there's something here where you can change the view. And one thing that I have is a aggregated mode. If we do that, you will see that the statistic is changing, and it will group the conversations by pairs. So let's say here on top you see this IP and this IP has only one connection. This IP here, these two, have two connections. So it will group the TCP connections under the IP pairs. Okay, sometimes that is interesting to do that. Yes? Yeah, I can't either. It's the default highlighting. As soon as you click on something, it's like gray text with a blue bar. That is stupid. So I need to figure out how to invert the colors. Yeah, that is something, you're absolutely right, that is not readable at all. Yeah, so here we have 4 connections under these two. So that is just something, if you want to see how many connections are between 2 IP addresses, you could do that. Go into aggregated mode and then you have that kind of thing. And you can toggle it back, of course, to the normal view. The normal view is just listed by first appearance. Yeah. So if you're in the normal view, each connection is listed by order of appearance. Okay, that is one thing, but that was the easy part. Now we're going into the more complex extraction things, and let me show you how that works. So, remove the edit. No, that was bad. I think I need to kill TraceWrangler. Die. Yeah. Okay. What is that stupid thing? Where's TraceWrangler now? Oh, I just want to shut it down. There it is. Go away. Okay, I start a new one. There it is. I add the files again. Where's my file selector? There. Okay, so let's do the more complex extraction as soon as all the database loading has finished. There. So now I have the extract from files button, and that one gives me a whole lot of different options. For example, if I want to extract all the, let's say, HTTP packets, everything that is HTTP, I could just go in here and say add a filter, and I want to filter on port pair, not port pair, but a source or destination port. So if it's port 80, I want to have it, and I call this HTTP, right? So, and I also want to, let's say, extract everything that is DNS. But DNS can run on TCP or UDP, so instead of TCP, I select TCP/UDP, so now this is DNS. Okay. And now I have two different filters. They will match each packet that has either port 80 or port 53, and will extract them. But I don't want to mix DNS and HTTP. I want to have them in different files, okay? I want to have one file per protocol. So what I do now is I go into my output settings, and you can see here this file name thing that I mentioned before. Usually if I keep it this way, source IP, source port, destination IP, destination port, I will get one file per socket pair, so to speak. But what I want instead is I want the protocol names. So I use a trick and say instead of all of those values, I use something that is called filter label. As you have seen that I called one filter HTTP and the other one was called DNS, right? So I just can use that filter name now as a file name. So while extracting, TraceWrangler will check, does this packet match a filter? If yes, okay, what is the name of the filter? Oh, it's HTTP. It puts that into the file name. It finds the file, if it exists, and appends the packet to that one, or if it's a new file, it just creates a new file. So let's just do that, filter label. Okay. And now we have a task that we can run, and to make sure that we see the results, I'll open up the folder where it's in. There will be a subfolder called extracted when I run this. So let's run it. There is it, there it is. And you can see I got one file that is HTTP and I got one that is DNS. And it's probably, yeah, it's still running. You can see here it takes a while. But still, this is a lot faster than doing that for HTTP ones over all files, for doing it for DNS ones over all files. Sometimes I run like 10 extractions at the same time. So give me all the ICMP, give me all the DNS, give me all the Kerberos, give me all the RDP, give me all HTTP, give me all SSH, give me everything that is whatever. And you just need to run it once and you get separate files per protocol. So that is really nice to afterwards search through a subset where just the protocol is in there. So if you have like a terabyte of data, you can split them by protocol that way really easily. Very often I let that run overnight because in the morning I have my files and I can work with them.
Question.
Yeah.
Is this multi-threaded, or do you each filter per thread?
The problem is that I need, so the question was, can this be multi-threaded? The problem is that I need to read the packets one by one and basically parse them. And then, yes, you're right, I could probably multi-thread this, but I haven't yet. Yeah. The reason is that I'm not a programmer. I'm a network analyst that also knows how to program a little, but I wouldn't consider myself a programmer. So the one thing that I didn't dare to do is write a program like this and immediately start with multi-threading, because troubleshooting that is like a nightmare. Yeah, so I try to do it single-threaded, and as soon as I'm at a point where I'm like, hey, this works really great, now I need to make it faster, then I will go into that. Yeah, but you're absolutely right, I could do that in this case because there's no packet dependency. Usually you cannot use multi-threading because very often packets that you're processing depend on findings that you have from other packets. But in this case, you're absolutely right, I could just do a multi-threaded matching. I haven't yet, but I hope I will at some point. First, I need to do a Mac version and a Linux version so that people stop nagging me, because they do all the time. Question?
Do you need the UI up and running while it processes this, or can you just run it from the command line?
Command line?
Yeah.
I will show you some news about the command line thing, yes. Good question, but I will show you later. This is still running. Okay, I show you now because this is still running, okay? Betty's not here, right? Betty? I would have heard her by now. Betty keeps nagging me about Mac versions, right? And the Mac version is a problem because this is all Windows GUI stuff, but a command line version would be nice. First of all, because command line version is just smaller, easier to use sometimes, and faster, maybe. And you can trigger it from other programs. So I was working on the command line version, and about a week ago, I got something for you. And that is called Wrangle. It can only do sanitization right now. And that has taken me like 5 months to get there because the GUI version writes all the settings into an SQLite database. And that is not really useful if you have a command line version because you don't want to create a database file and figure out how to write the tables and fields just to run a command line version. So what I needed to do is I needed to create a command line parameter file that is human readable and useful. And that took like 4 months to do because it needed to be interoperable with the GUI version. And that is really hard. There's also a reason why at the Ethernet that you saw, there's a couple of items missing because I removed the checkbox because that is stupid for command line parameter files. And I forgot to add the new options that I moved there. So that's why they're missing. So right now the Wrangle command, it can only sanitize stuff. But let's see, we can just take a look. And let's say we delete the HTTP anon thing that we did before. So now I make a command line sanitization and say Wrangle sanitize HTTP sample. And there is our HTTP sample anon. And it looks like this. You can tell that it's not the same as before because there's no sanitized by TraceWrangler thingy here because this is the default config that just cuts away the remaining bytes. As you can see here, there is an option in Wrangle to, where is it? There. You can give it, instead of a command, instead of the sanitize, which will just run the default sanitization, you can give it a settings file, and you can configure everything that we see in the GUI in the settings file, and then run that on the command line. So yes, I have it now, but it's all, right now limited to sanitization, because that's what people need the most. So the next question that usually comes up is, okay, if you have the command line version, what about running it on a Mac OS? And the problem with that is that right now my loading routines for the PCAP files are using Windows mapped files, which is the fastest way to read files on Windows. And that doesn't work on macOS. So what I need to do next is rewrite all of the loading routines so that they're compatible on all operating systems. I wanted to do that before SharkFest, especially since I have a talk about capture file formats tomorrow, but I didn't. I wasn't able to just for running out of time because, well, a lot of other things going on. So to have a Mac OS version, and I'm pretty sure I can get there, I need to rewrite the loading routines first. So that's another, I don't know, month, maybe 2, 3, we'll see. But as soon as I have it, you will notice probably, because Betty will be screaming out of joy so loud that you will hear it all over the US. Okay? We'll see. So that is just a little thing that I did. Okay, this is almost done. We can wait for the rest of it probably. So,
Do you have anybody helping you do this stuff? Or
no,
all in your own project?
it's all me. Everything is me. So I'm not using any libraries, any foreign code, nothing. The loading, the parsing, the reassembly, the sanitization, extraction, everything is mine. So it's right now I think 200,000 lines of code, just me being me, doing that for fun because I found it interesting. Most people are like, hey, you're crazy, but I think it's interesting to do this. And yeah, people sometimes offer me to help me, but as soon as I tell them, yeah, well, my environment, because I'm not a programmer, I'm an analyst, I'm doing this in Delphi, everybody's like, what's Delphi? Who's using that except the Russians, probably. Yeah, so no, nobody's helping me right now. Yeah. You find a lot of malware written by the Russians in Delphi, which is why I make this joke usually. Yes?
So have you ever had discussions about rolling this into the Wireshark project?
Rolling this into the Wireshark project. Yes, there has been this kind of discussion, briefly. Maybe it will. But right now, I would be happy to do that, because then I get more exposure, of course. But since I only have the Windows version right now, a lot of people would be crying at me like, where's the Mac version, where's the Linux version? And I want to do that as soon as I have at least the command line versions. Then I can say, hey, it's cross-platform just like Wireshark and it is more useful. But yes, absolutely, that is something that we're thinking about. Okay, is it done? It's done, right? Okay, so now we see that we have a ton of packets here. We have almost 2.3 gigabytes of HTTP, so I'm not going to open that because it will take a long time. This laptop is very old and only has 8 gigabytes of RAM, and I don't want to do that, but let's take a look at the DNS thing. And you should see that this is just DNS. Yeah, so the fun thing here is that you can basically work with this output file name and tell TraceWrangler how do you want the packets assembled in files. So you can make one big file, you can split them by IP address, you can split them by IP address in filter label. There's a ton of options in there if we look at them. And the idea is to make it as flexible as possible for you to write the packets to a file of, the type that you choose. Yeah, so very often I write things to IP address pair files so that I have everything that is going on between two IPs in just one file. Yeah, or I use the filter label, or I use the destination port and write only the HTTP stuff or the DNS stuff. You can use VLAN IDs, source IP, destination IPs, MAC addresses, whatever. Yeah, so that is really flexible, and I mean, I have my biggest problem is that this file name thing here, it looks so like just a file name, right? But there's enormous power behind it because of the labels that you can use. That defines what the output is like, right? Okay, so that is extraction. I also have other extraction features that I'm not going to cover today because my time is running out. And that is, you can, for example, if you're having snort rules that you want to check, I use this also to carve all the packets of the conversations from the files that had a snort hit. Okay, you could do that too if you want to. Anybody interested in seeing that, how that is done? If nobody raises their hand, I will just skip over it. If you're interested in that and didn't try to raise your hand or you didn't dare to, just see me later. I will show it to you one-on-one, basically. So that is something that I had to do a lot, like verifying hits in snort in the PCAP files, and that drove me crazy, so I put it into the extraction tasks. Okay, so that is that. Back to slides. Tools, I already showed you the tools in a way that basically these communication details are up here. What you also can do here is you can rename files. For example, if this name here is not what I want, I can go in here and say rename files, and you can rename them with a pattern as well. So sometimes that is helpful if you need to change the file names. Yeah. Right now, I think we're good with what we have, but that is another option that he could do. Other than that, basically, we have the merge file option that will allow you to merge files together into one big file, and that is not that useful anymore since MergeCap now is also capable of doing that with multiple interfaces. Usually it was a problem that if you had to capture where packets were captured on more than one network card at the same time, MergeCap would just not be able to do that. And in here you can define what you want to do with multiple interfaces. You can merge them together, you can create unique interfaces or map them all to one. That is just something that may be helpful, but very few people use. So usually everybody that I know of uses the anonymization feature. That is what is usually the one thing that everybody wants to do, or editing or extracting. Okay? So it's a first for me, but I think I'm 6 minutes early. If there's any questions, now's the time. Yes, please.
A question about, is there any features or any plans for any features to compare files? So
compare files?
Yeah.
Okay, comparing files is a very complicated thing to do. Right now there's a tool by the TribeLab guys. I don't know if you know that one. Okay, let me show you. Paul Offord and his team has created something called Workbench. Where's my Zoom? There's my Zoom. I think they're called TribeLab. And there's something here, Workbench for network engineers, and that thing can compare trace files for you.
Can you extract based on a string in any arbitrary string? Like if I'm looking for someone hitting a particular website.
So once again, somebody was dropping something.
Oh, sorry. So can you extract based on an arbitrary string?
Not right now, but there would be a workaround if you define a snort rule for that string, and then you run snort over your files, and then use the extraction task with the snort setting that I could show you. You could do that. Right now I don't have a pattern matching because I didn't have time to put it in there. Maybe I will do that in the future if that's helpful for you, of course. Okay.
What's your most current version that you have available for distribution that we could get?
Yeah, that's a good question because I'm an idiot, and what I have is on my webpage a so-called stable version. And the stable version is usually not the latest version. There's a nightly build that is much more recent and as stable as the stable version, which is why it doesn't make no sense to call the other one a stable version because they're all more or less stable. I think it was out of being afraid that if I put some new code in and people use it, it crashes. Well, the old one crashes more than the new one usually. So very often I had people come to me and say, hey, this crashes, and I find out that, yeah, it did crash, but in the latest version it doesn't anymore, but they didn't use that because that one they used was a stable version. So my tip right now, because I'm going to change that in the future, is you go to TraceWrangler.com, and as you can see, I'm also not a web designer, right? This looks like it used to when we started doing the web stuff. There's something called the semi-automated build section. And if you go there, this is where you will find the latest version, and that is from 3rd of February 2019. So right now, I would recommend just go to that directory and get that version because the stable is so old that it crashes for reasons that this one doesn't. And what I will do is I will change the website to a mode where I will be able to find the most recent version much more easily, because right now that is just me being lazy and stupid. Maybe Angelo needs to do a website design for me so that it looks nicer. But it's fast because no design, right? Okay, anything else? If not, enjoy your break. Thank you, and see you next time maybe.